Welcome back, everyone. And in today's video lesson, we are going to look at consonants and dissonance in intervals. Now let's just do a quick review. Consonants are going to be notes that sound good together, and dissonance would be the inverse of that, right? They're going to be notes that sound bad together when I play them together. So I have a key here that I've written, and this key is going to help us determine what we're going to label in a little bit. So if I write a big capital C, we're going to say that that's going to represent something that is very consonant. If I write a lowercase c, that's just going to be mildly consonant. A big capital D is going to be very dissonant. And finally, if I have a lowercase d, we're just going to call that dissonant, right? So it could be some spectrum. And so we want to think about our scale as being something like this. And maybe something that is very consonant would be over here. Very, very consonant, very, very dissonant. And we'll have some amount of dissonance, here, and some amount of consonance here. And if we sort of cross this line, that it's going to flip to be more dissonant than consonant. So now looking at our intervals, let's go ahead and label them. And I would label this as very consonant, very consonant, very consonant, and missing the major third, which is also very, very consonant. Let's go ahead and grab our very dissonant intervals. And that would be something like, this is very dissonant, this is very dissonant, this is very dissonant. And so that leaves us with the rest of our intervals, which are going to be a bit of a mixture. And so we're going to say that this is mildly dissonant, and this is mildly consonant. Mildly consonant, and then this is going to be mildly consonant, and mildly dissonant. Okay, so now we can definitely see a pattern. We've got 4 big C's, we've got 3 big D's, and then we've got kind of a smattering of other D's and C's, lowercase. All right, so now let's rearrange them in some kind of an order. And if I were to do that, we would have our P1 would go here, and I'm going to stack that up with my P8. And the reason why I'm going to stack those together is because I believe that they're essentially the same amount of consonants. There's no change in the consonant scale there because we're talking about the same pitch class. So P1 and P8. Then I would go over here and say, well, P5 and major 3. And that's slightly less consonant, very, very slightly less consonant than our P1s and P8s, but it is a little bit less. And if we continue on, then we would probably say something like minor 3rd and major 6th. And if we go a little further, maybe a P4 right about here. And if we go all the way to the far end of this side, we would have something like minor 7, major 2nd, major 7, minor 2nd, and A4 and diminished 5th. And so this gives you an idea, sort of a spectrum of where they lie at. And we can see what this says. It's 100% consonant and 0% dissonance. That's fairly true. 50% consonant, 50% dissonance. We're about to cross the line where it becomes more dissonant than consonants. And then we have 0% consonants and 100% dissonance. Now there's a couple of things I want to mention about this. Number one, I want to say that this is a very subjective scale. So the idea that I'm really trying to get across here is this P1 is definitely going to be more consonant than this minor 3rd. Or anything that's a capital C is certainly going to be more consonant than any D or lowercase c. Okay, so that's the idea. That's the subjectiveness of the scale. And so what I mean is someone else might look over here and they go, well, maybe I think that a minor 7 is a little more dissonant than a major 2nd. And so maybe these don't need to be stacked up. They need to be separated a little bit. Or maybe someone else says, you know what, I think we should kind of flip these two. Or I think this P4 needs to be in line with this P5. And that's okay if you think that. This can be looked at from a physics perspective, which I don't want to do that. We just want to sort of take it from a gut perspective. How does this make you feel and how does it sound when we listen to it? So this is sort of a general perspective. Now, the one thing too that you can really consider about this is that this P1 will always be more consonant than a minor third. And that's something that is absolutely irrefutable. You can't argue with that a P1 is more consonant than a minor third, that a major third is more consonant than a minor third, that a P5 is more consonant than a minor third. Those are irrefutable facts. A P5 is more consonant than a minor 6 or a major 6 or a minor 7 or a major 7. Irrefutable facts. Major 7 is more dissonant than minor 7, major 6, minor 6, so on and so forth. Irrefutable facts, okay? So those are kind of the big tenements to think about. Now, the other thing that we want to consider is that with this scale, I'm really only considering notes that are in tune, right? So could we have more dissonance? Yeah, we could completely change our tuning scale or have an instrument that is not really in tune, and then you'd have just far more dissonance. So we're considering 100% dissonant just to be an instrument that was already in tune. But the truth is, you could have an instrument out of tune and you'd actually experience even more dissonance that way. We're not looking at that because that doesn't matter to us. We want to have our instruments in tune. Now let's look at how does distance affect dissonance. So if I had just a note that was from C to D, well, this is just our regular amount of dissonance, right? This is nothing special here. So this is just normal. But if I had something like, what if I had a note that was C to an octave up, C to another octave up, C to another octave up, C, and then to D. And so what I'm really looking at is how do these two notes compare? So I'm no longer really looking at like this section, like a C to a D, like that's what this would be. I'm looking at this really long section, right? C to C to C to C to D. In other words, this C compared with this D. And it turns out that this is going to give us reduced dissonance. Now, this is a really strange effect. Why does this give us less dissonance if we just talked about that these have a certain amount of dissonance? Well, the reason why is it's not so much that it actually gives you less dissonance. What really happens is it tricks your ear. Your ear has a hard time dividing the frequencies and understanding, well, what frequencies are where. Because that's essentially what your ear and your brains do. It's going to look at the two notes and it compares the frequencies. And if they're readily divisible, then it says these notes are consonant. And if they're not readily divisible, it goes, these notes are dissonant. And let me give you a really quick example of that. If I were to take two numbers and I had a 4 and then I had an 8, your ear would go, aha, that is easily divisible. And your ear would go, okay, those are consonant. If I had a note that was a 15 and a 3, your ear would go, aha, those notes are readily divisible, so I could bring this down to just 5/1. All right, now, if I had something that was like 16/3, your ear would go, I don't know how to divide that. So I'm going to call that dissonant. And if I think about that, I don't know what number that's going to be. That's obviously going to be 5 and change. That's 5 point some large decimal that never ends. That's our best approximation. There's no exact decimal number for something like that. And that's exactly what your ear is doing. Now, as we get further and further out in the spectrum from a very low note to a very high note, your ear has a hard time determining something like this. Versus when the notes are close together, it's very easy to see that it's divisible. And we can experience this in a visual way as well. For example, what if I said something like this? 5,963, is that divisible by 11? Well, heck if I know. I don't know. I need a calculator. Or I need to sit and do the math. You can see what I'm talking about. So from a visual perspective, already you can tell, I don't know if that's divisible by 11 or not. Now, if I had told you, is 22 divisible by 11? Oh, yeah, sure, that's divisible by 11. That's going to be 2/1. Right, so this is the same exact sort of thing that goes on with your ears. And when your ear hears something like this, where the notes are really separated, let's look at this as a very high frequency and a very low frequency. Your ear goes, I don't really know if they're completely divisible. So in that respect, we're just going to say that they're more consonant. And so that's how we sort of lose dissonance. That's how we have reduced dissonance when we separate frequencies.